We sent 12 of the most popular peanut butters in America to an independent food safety laboratory, and what came back on the report didn't just surprise us, it surprised the chemists who ran the tests, several of whom have spent decades analyzing packaged foods and said they rarely see results like this from a product marketed as a wholesome pantry staple. Peanut butter sits in nearly 90% of American households. It's the sandwich-filling parents pack for their kids, the protein boost gym goers spread on toast, the late-night spoonful straight from the jar that almost nobody admits to, but everybody does. It has a reputation as one of the simplest, most honest foods on the shelf. Peanuts, maybe some salt, maybe a little oil. That reputation is exactly why we wanted to test it, because when a food category earns that kind of unquestioned trust, manufacturers know consumers stop reading labels. We purchased 12 jars from major retailers, chosen to represent the full spectrum of what's actually in American pantries. The massive national brands that dominate supermarket shelf space, the natural and organic labels that charge a premium for perceived purity, the store brands people buy to save money, and a couple of newer direct-to-consumer brands riding the high-protein wave on social media. Every jar was purchased anonymously, in person, with cash, specifically so no manufacturer could trace the purchase back to us and swap in a cleaner sample. That's a step most consumer testing skips, and it matters, because food companies have been caught before sending golden samples when they know a lab is watching. The first thing the lab checked was aflatoxin, a naturally occurring toxin produced by mold that grows on peanuts, and one of the most potent liver carcinogens known to science. The FDA sets an action level of 20 parts per billion for aflatoxin in peanut products, a threshold that sounds reassuringly strict until you learn how it was set, not based on what's actually safe for long-term daily consumption, but based on what level of contamination was considered economically unavoidable in bulk peanut processing decades ago. 10 of the 12 jars came back with detectable aflatoxin. None crossed the legal action level, which is the number regulators will point to and call this a non-story. But 3 of the 10 showed levels the lab's toxicologist described as closer to the ceiling than any of us are comfortable seeing in a product eaten daily by children. And one of those 3 was a brand marketed explicitly as a healthy, natural choice, with peanuts sourced from a supply chain the company's own website describes as rigorously quality controlled. The gap between marketing language and laboratory reality was, in the lab director's words, not a great look. Then there was the question of what else was hiding in these jars beyond the peanuts themselves. Heavy metal testing revealed detectable lead in 8 of the 12 samples, and detectable cadmium in 9 of them. Peanuts are what's known in food science as a bioaccumulator. They grow underground and absorb whatever heavy metals are present in the soil around them, which means contamination isn't necessarily the fault of any single manufacturer, but a reflection of decades of industrial runoff, pesticide history, and soil quality in the growing regions. Still, the levels varied dramatically between brands, which tells you sourcing and supplier vetting matter enormously. And not every company is doing that vetting with the same rigor. The 2 samples with the highest cadmium readings both traced back to peanuts grown in regions with known industrial contamination histories. According to agricultural data, the lab cross-referenced, and neither of those brands discloses sourcing region on the label, which means, as a shopper, you have no way of knowing which jar in front of you carries that risk and which doesn't. Beyond contamination, the lab also ran a full ingredient verification panel, essentially checking whether what's printed on the label matches what's actually inside the jar. And this is where things got genuinely uncomfortable. Several jars labeled simply peanuts, salt, tested positive for palm oil derivatives and stabilizing agents not listed anywhere on the ingredient panel. In concentrations, the lab chemist said were too consistent to be cross-contamination from a shared factory line. They appeared deliberately formulated into the product. Undisclosed added sugars turned up in 4 jars that market themselves as no sugar added or natural. In one case, at a level the lab estimated at nearly a teaspoon per serving, hidden not as cane sugar but as a corn-derived sweetening agent that doesn't have to be declared the same way under current labeling loopholes. This is a pattern investigative food journalists have flagged for years, companies exploiting the technical letter of labeling law while violating its obvious spirit. And it was validated right here in 12 jars bought off an ordinary supermarket shelf. Rancidity and oxidation testing added another layer. Peanut butter, like all products high in unsaturated fat, degrades over time through oxidation, producing compounds that not only taste off, but have been associated with inflammatory processes in the body when consumed regularly. Peroxide value testing, which measures early-stage oxidation, showed 3 jars already trending toward levels associated with rancidity, despite being well within their printed shelf life, suggesting either poor storage somewhere in the supply chain before it ever reached the store, or manufacturing processes that don't adequately protect the product from oxygen exposure during production. The lab's food chemist noted, "This is a quieter but genuinely more common problem across the entire category than contamination. Most peanut butter on shelves today," she said, "is already partway down the oxidation curve by the time it reaches a consumer's pantry, and almost nobody can taste the difference until it's fairly advanced, which means people are unknowingly eating oxidized fats on a near daily basis and attributing any resulting fatigue or inflammation to literally anything else in their diet." What made the scientists visibly uneasy, according to two people present during the results review, wasn't any single finding. It was the accumulation. A little aflatoxin here, undisclosed additives there, heavy metals in nearly every jar, oxidation creeping in ahead of schedule, and a labeling system that gives consumers almost no reliable way to distinguish the responsible manufacturers from the negligent ones just by reading the front of the jar. One toxicologist put it bluntly during the debrief, "None of this would fail an FDA inspection tomorrow. That's not the same thing as it being fine to eat every single day for 30 years. That distinction between technically legal and actually safe long-term, quintos, is the entire story regulators don't want told, because acknowledging it opens up a conversation about how outdated and industry-friendly a lot of these action levels and disclosure rules actually are. Rules that, in some cases, haven't been meaningfully revisited since the 1970s. So what do you actually do with this information the next time you're standing in the peanut butter aisle? The lab's recommendations, for what they're worth, were consistent and fairly simple. Favor brands that explicitly disclose sourcing region for their peanuts, since traceability correlates strongly with lower contamination in this dataset. Be skeptical of natural and premium organic labeling specifically, not because organic certification is meaningless, but because in this test, some of the worst offenders on aflatoxin and hidden additives were sold at premium prices under exactly that kind of trust signaling language, which suggests marketing budgets, not manufacturing rigor, are driving some of these claims. Buy smaller jars and finish them faster. Since oxidation compounds over time and a jar sitting half used in a pantry for 4 months is a meaningfully different product than the one you opened on day one. And read past the front label to the actual ingredient panel every single time, because in this test, the gap between what a jar claimed to be and what a laboratory proved it actually contained was, more often than not, the entire story. None of this means peanut butter should disappear from your kitchen. It remains, even with everything we found, a relatively efficient source of protein and healthy fat for the price. But the idea that it is some untouchable, unimpeachably clean food, the jar you never have to think twice about, does not survive contact with a laboratory report. And if a food this simple, this trusted, this deeply embedded in the American pantry can hide this much once you actually look, it raises an uncomfortable question about everything else sitting on that same shelf that nobody has bothered to test yet.